Hey, what's up guys? This video is for section 9.2, which is solving quadratic equations by graphing. And it's not so much as graphing by hand, but we are going to use a tool in order to graph a parabola, a quadratic equation. And looking at the graph, we are going to look for the x-intercepts or solutions, or we can also say we are going to find the roots of that equation or zeros. They all mean the same thing. All those names, we just want to know what the x value is in a quadratic equation. So we're trying to find the value of x. So let's go ahead and look how we are going to read the graphs. And when you guys graph a parabola, you have three options, meaning that where it touches the x-axis or it doesn't touch the x-axis. Keep in mind that a parabola, it has two directions. It can go up or it can go down. So the first option here, you guys see the parabola going down, but we're not looking for so much as the direction of the parabola. We are looking at where does it cross the x-axis. So looking at this graph right here, we notice that on the x-axis, the U shape is touching 2 times. And I'm just going to put 2 points right there so you know that it is crossing. It is going through 2 different points. So what does it mean? It means that we have 2 unique real solutions. So those numbers for the x values on the x-axis will be our answer for the x value. Same thing with the next parabola. The next parabola is right here. So you guys can have 1 point on the x-axis, and in this case it is the vertex on the x-axis. So since it is touching the parabola 1 time on the x-axis, it is 1 real solution. And the next option here is where the parabola, and it doesn't matter if it goes up or down, is not touching the x-axis at all. It's not going through the x-axis. So when that happens, we say there's no real solutions. So which means we have imaginary solutions, but in this class for Algebra 1, we are not talking about imaginary solutions, just real. So we say no real solutions. Now let's go back here on the 2 unique real solutions. When you guys want to solve, you want to know what is the x value in that x-axis where the parabola crosses or touches the axis. So here, I'm just going to make an estimation. I know the origin is here. So I'm going to say this is -1. So that's my x solution or my x point, x coordinate. So my solution is -1. But I have another one at +1. And remember that I'm just estimating. I don't have any units. So I can't really say it's -1 or +1. But it's just something that it makes sense. This one here, it is a 1 here, so I'm going to say x equals, and let me just put here, x equals -1. So that's going to be my solution for this parabola because it is touching the x-axis, and that's what we look for, where does it touch or crosses the x-axis. Let me go back to this parabola, and I'm just going to write down what I estimated right now. So x equals +1, and on this side, x equals -1. So we have 2 real solutions, 2 answers. Here we have 1 answer. Well, this one is just no real solutions because it's not crossing the x-axis. So let's look at these 3 graphs on the screen. The first one, you notice we have the parabola going down, and the point that is touching the x-axis, I'm just going to make a big X here so you know that's the x-axis, that's the y-axis. Well, the point is here. Now, what is the x coordinate or the x value on that point? Well, I'm just going to look at the x-axis. Here's the origin, 1, 2, 3. So it is x equals 3. So my solution is that, x equals 3. I want to know what the answer is. So I'm saying that the value of x is 3 because that's where it touches the x-axis. And that's reading your graph. The graph is already done for us. Sometimes it is already done. Sometimes we have to use a tool to graph the parabola, and then we have to look for those solutions. Now let's look at the next one. The next one, oh, and let me just go back here. This here means that we have 1 real solution because it touches 1 time on the x-axis. This one, well, I'm looking at the parabola. The parabola is going down, but the x-axis is up here. The parabola is not even touching the x-axis. So for this one, we say no real solutions because the parabola is not touching the x-axis. So no real solutions. You guys don't have any values of x's. The parabola are not touching any points on that axis. And the third one, just really fast here, I do have 2 points. I have a point here and one here. So let's look for this one. On the left side, x equals -2. That's on the x-axis from the origin, -2. And on the other side, it's a +1. So x equals +1. So my 2 answers, my 2 solutions, that's what we say, 2 real solutions are -2 and +1. So let's do that. Let's try some examples where you guys have the graph and you want to find what is the x value or the x-intercepts, and that's what we're looking for once again. You guys want to know where it crosses the x-axis. Another name we can use, there's a few. One is zeros. What are the zeros of the quadratic equation? What are the roots? Or you guys can say x-intercepts or solutions. So you guys see these 2 graphs here, and we want to solve by graphing. And one more time, the graph is already done for us. So when you look at this equation, x squared minus 2x minus 8 equal to 0. And I already showed you guys one way to solve for that x without the graph, which is by factoring. You guys factor the trinomial, you find the 2 parentheses, the 2 factors, you equal that to 0. You use the zero product property, and then you can solve. But once again, we are reading the graph here. So what am I looking for? The parabola of this equation is already on the graph. So we have the U-shape going up, and it makes sense because the a value is 1. The y-intercept is -8, so you guys can see the y-intercept, but we're not looking for that. We are looking for the x-intercepts. So one of them, and I'm just looking at the graph, is right here, and the other one, the other x-intercept is right there. So for this one, x equals -2 from the origin, that's -2. And this one here is 1, 2, 3, 4. So x equals +4. So those are my 2 answers. My 2 solutions are -2 and +4 because that's where it crosses the x-axis. When you guys look for those points, the x-axis, the name 0 comes from the y is equal to 0. And that's what we want. We want to know the solution. Now the next graph, which is this one here, 2x squared minus 3x plus 5 equal to 0. Well, the parabola is up here and is going up. The x-axis is down here. It's not touching the x-axis. So guess what? We have no real solutions because we cannot see, we don't find this, where the parabola crosses the x-axis. It doesn't. So we say no real solutions. And we have our answers. So make sure that you guys know how to read the graph and just look for those x-intercepts. Now, let's say you guys don't have the actual graph on paper, which means you're going to have to use a tool. Now, there's a few ways or a few tools you can use, and one of them is a graphing calculator. Another one is an app that is free. It's called Desmos. You guys can download it to your cell phone. You guys can download it to your tablet. You can use it online on your computer, on your PC or Mac. But you guys can use Desmos to graph the parabola and look for those x-intercepts. And there's a few more apps, graphing apps you can use, but I like Desmos. So let's try the next one. So here, notice that we do have the 2 graphs, but they don't have we have the equations, but they don't have the graphs. That's what I meant. So the first thing is to actually graph the parabola, and then you guys are going to look for the x-intercepts. When you graph the parabola, I am not looking for accuracy. You're not going to make a very good, very perfect parabola, but you guys will make a kind of like a overall overview parabola, and that's going to help you guys find the x-intercepts. So the first one, the first equation, we have x squared equals -8x minus 16. when you guys want to use an app to graph the parabola, you must have everything equal to 0, because that 0 is going to work as your y in the function, in the equation. So I'm going to get everything to one side. So first, for this equation here, I want to do the opposite of the minus 8. So I'm going to add 8x to both sides, and I'm going to add 16 at the same time because I want everything on the other side. So I do the opposite. Over here, I'm going to add 8x, and I'm going to add 16. So when I combine here, there are no like terms, so I cannot really combine like terms, but I can set them up as the standard form, and that's going to be x squared plus 8x plus 16 equal to 0. Now notice, we do have a 0 on one side, so that 0 works like your y. So when you graph it, the only thing you're going to graph is this trinomial, but make sure that you guys have everything on one side and equal to 0. So notice that I already have the equation in this app Desmos, and if you guys are wondering, online you guys can go to www.desmos.com, or you guys can download the app for free on your cell phone or tablet. So the graph, you guys see it right in there. You guys have the U shape going up here, and I want to know what is the actual x-intercept. So looking at the x-intercept right there, guys, we have a 1, -1, -2, -3, -4. So my solution is at x equals -4. That is my x value. So let me just move this on the side, and I'm going to start doing the parabola on the actual graph here. So let me go back to my graph. We notice that the parabola crosses at x equals -4. So I'm going to put the point again, 1, -1, -2, -3, -4 is right here, x equals -4. And my U-shape, I'm not going to make a great U-shape, but I want you guys to actually just copy the parabola, and doesn't have to be accurate for today. Yesterday, on the previous video, I did show you guys the steps to graph a parabola in standard form, and later on we're going to do more graphing by hand. But today we're just going to have like an idea what the graph looks like. And you guys do have your answer as x equals -4. Now this example, guys, is x squared minus 6x equals -11. So the first thing we have to do in order to graph it to solve by graphing, let's go ahead and have everything equal to one side. So I am going to add 11 to both sides, plus 11 here and plus 11 over here. So we have x squared minus 6x plus 11 equal to 0. Using the app again, I'm going to graph it, and I'm going to show you guys the app right now. So there is the graph on your right side of the screen, and we do have a U shape here. Notice that on the actual app, right here, when I input the actual function, I don't use a 0, I actually use a y. Let me just make this a little bit bigger to show you guys the y here. That's because we are graphing the function. So we have a y equals x squared minus 6x plus 11. Everything else is the same as the equation, the trinomial, but I'm using the y instead of a 0. The x-axis, if I'm looking at the graph here, the x-axis is right down here, but the U-shape is on top of the x-axis. Now notice that it's not crossing that axis. So what that means is we have no real solutions. This point here, it is the vertex of the parabola, but it's not on the x-axis. The parabola is not crossing to, the x-axis. So what we're going to write down here, and my solution would be no real solutions on this one. Once again, because we have the parabola on top of the x-axis, it is not crossing or touching the x-axis. So no real solutions. Now I want you guys to actually graph the functions, okay, or the parabola. It's not going to be exact, but I want you guys to do the vertex right here of your parabola. So it is 3, 2. So I'm just going to make a point at 3, 1, 2, 3 to the right, 1, 2 up, and I make my point right here, and I make my U shape going up. And this is not exact, but you guys do have the parabola the U shape going up, and we have an idea what it looks like. But the main thing is that it's not crossing the x-axis, so we have a no real solution. Now this one, guys, it says here you want to solve by graphing, but we want to round the answer to the nearest tenth, which means that we are going to have a decimal answer. The question that we want to solve is negative x squared minus 3x plus 7 equal to 0. So we already have the 0 on one side. That's what we want. That's good. When you guys graph it, remember that you don't need to put or equal to 0. We need the y equals instead of the 0, and the trinomial negative x squared minus 3x plus 7 is the one we want to graph. So I'm going to show you guys the graph here, and when you guys look at the x-axis, you notice that the parabola is crossing that axis. So the x-axis is here. We have 2 points here, and decimals, that's what's nice about this app. It gives you guys the actual value of those x-intercepts, or where it touches the x-axis. The parabola touches the x-axis. So one of them, this one, is at negative 4.541, and this one is 1.54. So we have our two answers, and we want to round to the nearest tenth, which means one number after the decimal. Now, since we are going to graph on the coordinate plane, it's a very good idea to know what the vertex is. So using decimals, we also have the vertex here, which is at negative 1.5 and 2.25. They're all decimals, but they're going to help us to graph the parabola. So when I go here, I'm going to keep this on the side so I know what I need. And when you guys look at the solutions, well, first of all, let's write down the two intercepts. One of them is at negative 4.5. That's going to be round to the 10th because the 5 stays the same. Even though you have a 4 next to the 5, 5 doesn't round up. So I'm going to write that down here. X equals negative 4.5. So I'm going to make a point. 1, 2, 3, 4. 0.5 is right here. So that's your negative, and I'm going to write that down so you know x equals negative 4.5. And the other one is at 1.5. The 4 doesn't make the 5 to go up. So the next one is 1 positive 1.5. And I make a point at positive 1.5. 1.5 is right here. And I'm going to put x equals 1.5. So first of all, we got our answers. We know what the x values are, negative 4.5 and 1.5 to the nearest tenth. But now I'm going to plot the vertex, which is at negative 1.5 and 9.25. So from the origin, you go 1, negative 1.5, and then you go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and a little bit more, and you make a point right there. So that is your vertex. So all you do, guys, you connect the points and you make your parabola. So I'm going to make my U shape going up, and then you make your U shape going down, and we got ourselves the graph. Now the idea is solving by graphing, and we did graph because we have the parabola, but we do have the two x-intercepts, or the x values for this equation. And using decimals, you can graph it. Sometimes you can graph by hand, but when you guys graph by hand, it's not really accurate. So that's why I like to use decimals, so we can have the actual values. One more thing that I need to remind you guys is when you guys round to the nearest tenth. So let's say that I'm just going to make up a number here. Let's say that instead of this number, we have a negative 4.561. Notice that this number here next to the 5 is more than 5. So 6 is more than 5. So when you guys have this number next to the one you want to round, if it's 5 or higher, you're going to round this up. So this number here is going to round to approximately negative 4.6 because this 5 goes up 1, which is 6. So keep that in mind when you round into the nearest tenth in a decimal. Now the last one is kind of like an application problem where you guys are going to see how we use quadratic equations to solve a real world problem. So let's go ahead and read the question here. The problem, it says the height of a golf ball in the air can be modeled by the equation h equals negative 16t squared plus 76t, where h is the height in feet of the ball after t seconds. So we don't have x and y, but we do have an h and a t, and the t has a square. So that's where it comes, and you can say it's a quadratic equation because we have a variable with a square. Part A, it asks how long was the ball in the air. Part B, what is the ball's maximum height? And part C, when will the ball reach its maximum height? Okay, so just to give you guys an idea what this means, I'm going to draw a pretty bad drawing here, but it's going to give you guys an idea what this means. When you guys look at a golf ball, you guys know that that's on the ground. So let's say that's your golf ball right here, and I know it's pretty bad, and your ground is right here. The golf ball, before it's hit, it's on top of a tee. That's what it's called. So you have the ball here, and when someone hits it, well, the ball is going to go up, and then it's going to get to a maximum height, and it's going to come down, and eventually it's going to hit the ground right here. And yes, it's going to roll forward, but we're not looking at where it rolls. We just want to know when it hits the ground. So the starting point here goes up and it comes down. Well, guess what, guys? This path of the ball is a parabola. It's a U-shape, and it's upside down U-shape. And you guys notice this number here, the one with the t squared, is negative. That's your a value. When the a value is negative, the U-shape goes down. Okay, now we are looking for a few things. Number one, how long was the ball in the air? Now notice here it says that t represents seconds, so that's time. How many seconds was the ball in the air? T is kind of like your x value. So if you think about it, your x is your ground, your x-axis. So when you look at the x values, that's going to be seconds. Your height is like the y-axis when you guys go up. So your axis, your y-axis, your y is going to be your maximum height. So I'm going to use Desmos again, and I'm going to graph the equation. I'm not going to use h and k and t because with Desmos we need to use y and x. But it's going to be the same thing, just using different variables. So I do have the graph here with Desmos. Let me just make this bigger so you guys can see it on the screen. And the equation, once again, I am not using the h and the t because with Desmos we need the y and the x. So y is your h, the height, and x is your t, which is time. Now look at the parabola here. We have a parabola going through the origin, 0, 0. You guys see the point. It goes up and it comes down. Now this one is kind of like really high, but that's why I drew the picture, so it makes a little bit more sense. And notice a couple things. From here to here, that's where the ball is on the ground because that's your x-axis. So your x-axis will be your ground. Let me write that down. X is ground. Your height will be your y-axis. So the height is right over here. So imagine the ball is at the origin, and then someone hits the ball. It goes up, and then it comes down, and it hits the ground. Now look at the ball or the point up here. Nothing goes on top of this point because that's where the ball started to come down. So when it hit that point, it came down. So this here is your highest point, and the highest point is at 2.375 and 90.25. Now you have to make sense of the problem. You have to make sense of the numbers. So remember that x-axis is your ground and x is time. So what this means is you start at 0 seconds, and when the ball went up and it came down, it hit the ground at 4.75 seconds. So this right here is how many seconds it was on the air, because it went up 1 second, 2 seconds, 3 seconds, 4 seconds, boom, and it hit the ground. So for part A, it says here how long was the ball in the air. Well, we are going to say that it was 4.75 seconds. Part B, what is the maximum, the ball's maximum height? Well, that's where you guys look at the highest point of the parabola, and the highest point is right here. Now you guys are looking at the height. Remember that y is your height. So let me put here, h is your y, and t is your x, your time. So your maximum height is going to be 90.25 because that's how high it went from the ground. So part B, we are going to say the maximum height is 90.25, and it is feet because that's what it says, height is in feet right here. So we have 90.25. When would the ball reach its maximum height? So let's go back to that graph here. And the maximum height, well, we know that the maximum is this one. That's when it hits the maximum and then it came down. And this represents the time it took to get to this height. So 2.375 seconds. So let's write that down for part C. So we have 2.375 seconds. Let's go ahead and look at the drawing again so you guys can make more sense of the problem, because with the parabola using decimals it's a little bit weird. So here's the ball, golf ball. It hit right here, and right there is the maximum height. So that's where you guys have the points at 2.375 and 90.25 feet. So that's your point. So the actual golf ball went up, boom, maximum point, and then it came down. Now this one, the starting point, x is 0, or instead of x, let me just put, let me erase this here. We have t is 0, that's your x value, but over here, your time when it hit the ground is t, 4.75 seconds. So let's make sense. Starting point, 0 seconds. Someone hits it, 1 second, 2 seconds, 2.375, boom, it hit the maximum point. And then from here, it went down 4.75, boom, it hit the ground. So that's how many seconds it went from this point to this point right here. And that makes sense. When you throw an object, it can stay in the air for 2, 3 seconds, 4 seconds. It depends how far, how strong the object was thrown. So guys, this is the end of the video. So if you guys like my videos, you guys can hit that like button. You guys can subscribe to my channel, and make sure you guys practice your math, and I'll see you guys later.